Hello everyone, this is Pre-Calc Lesson 93, Advanced Trig Identities and Trig Inequalities. We're going to just jump into this and do some examples. I think that will make the most sense. So we want to show that 1 over sine b over cosine b is cosine b over 1 minus sine b. So we start with 1 plus sine b over cosine b. What I'm going to do is I'm going to multiply the top and the bottom by cosine b over cosine b. Now this becomes cosine squared b, which we know that, so on top I have cosine b times 1 plus sine of b. Cosine squared equals 1 minus sine squared of b. Okay, and I can now factor 1 minus sine squared of b because it is the difference of two squares. I can factor it into 1 minus sine of b times 1 plus sine of b. And the 1 plus sine of b's cancel, leaving me with cosine of b over 1 minus sine of b. This is how you should do these problems, by the way. Start with your left side and go until you get to the right side. Don't continually write this half of the equation. Okay, let's do another example. Tangent b plus 1 over tangent of b minus 1. Okay, that's what I'm trying to prove. Okay, so what I want to do is both of these have kind of the same form. I'm going to rewrite tangent as sine over cosine. Okay, so I will have sine of b over cosine of b plus 1 over sine of b cosine of b minus 1. Okay, and I'm going to multiply the top and the bottom by 1 over sine of b. Okay, if I do this, my sine of b's cancel here, so I have 1 over cosine of b plus 1 over sine of b over, I have 1 over cosine of b minus 1 over sine of b, which is secant of b plus cosecant of b over secant of b minus cosecant of b. And I'm done. Okay, just creating some new identities here. Let's do another one. Cover that up so it's not distracting. So we want to show that x sine of theta plus y cosine of theta squared plus x cosine of theta minus y sine of theta squared is x squared plus y squared. So I am going to FOIL out these terms. So I will have x squared sine squared of theta plus 2x sine of theta y cosine of theta plus y squared cosine squared of theta. That's this first term. Now this term I'll have x squared cosine squared of theta minus 2xy cosine of theta sine of theta plus y squared sine squared of theta. Okay, this term and this term cancel. Okay, I have cosine squared of theta, cosine squared of theta, sine squared of theta, sine squared of theta. Okay, so what I'm going to do, okay, I'm going to group my x terms and my y terms. So I'll have x squared sine squared of theta plus x squared cosine squared of theta. And I'll have y squared cosine squared of theta plus y squared sine squared of theta. Okay. I'm going to factor out x squared of this first term. So I have x squared times sine squared of theta plus cosine squared of theta. I'm going to factor out a y squared. So I'll have cosine squared of theta plus sine squared of theta. And we know that sine squared of theta plus cosine squared of theta is 1. So this gives me x squared plus y squared. Again, I'm just working with the left side of my equation, so just write the left side of your equation until you end up at the right side of your equation. You guys are trying to write both, and it's just getting really confusing. just do the left side of your equation. All right, now let's talk about triangle inequalities. Okay, triangle inequalities, we have a triangle inequality postulate that says the sum of two sides of a triangle must be greater than a third side. Okay, now our actual triangle inequalities look like this, our Pythagorean inequalities. If c squared equals a squared plus b squared, so if we have this triangle, this is a, b, and c, if c squared equals a squared plus b squared, then they have a right triangle. If c squared is greater than a squared plus b squared, we have an obtuse triangle. And if c squared is less than a squared plus b squared, we have an acute triangle. You actually went over this in Algebra 2, if you can remember way back when. But we're doing it again. So you'll be given problems like this that says, is the triangle whose sides are 3, 4, 5, is that a right triangle, acute, or obtuse? So we take the biggest side. The biggest side is always your c. So 5 squared is going to be something. We want to know, is it equal, greater than, or less than 3 squared plus 4 squared? So is 25 something 9 plus 16? It's equal. So I have a right triangle. Classify the triangle whose sides are 4, 7, and 5. So 7 is my largest, so 7 is my c squared is something greater than, less than, or equal to 4 squared plus 5 squared. So 49 is something to 16 plus 25, which 49 is greater than 41, which tells me this is obtuse. That is all for triangle inequalities. Okay? There's nothing more to it than that. And there's nothing more to this lesson. So I will leave you at that thought. Have a good evening.